All right, welcome back, guys. Oh my god. So this is part 3 of the series on and if it seems like I'm rushing through this, I apologize. I am super behind in this class. As now I haven't even started objective 3 and a final submission is due Tuesday. Yeah, I'm just very behind and I'm just trying to basically get everything done and up here before our final submission this Tuesday. But anyway, that was just a little disclaimer. So this next video I'm going to show you guys is basically it's just going to show you basically what the Great Pacific Garbage Patch actually looks like. And they also talk about in this also too the types of plastic they found within the patch, which I will later on talk about as well.
He looks like the captain of this garbage boat.
Scenes like this are a daily reality for the crew of Seeker on their Pacific trek. Some estimates hold that by 2050, there could be as much plastic as there are fish in the ocean.
Every day we see plastic.
I am already worried. That is why I want to show what is happening.
We go back with this net, so it's not only one net, it's many nets that are tangled together. Also some other very interesting items like this toothbrush was trapped in the net.
But what is all this junk exactly? Where does it come from? And is it really concentrated in a giant garbage patch somewhere out there? Marcus Erickson is an environmental scientist who has made it his life's mission to solve the problem of marine plastic. It's a global issue because plastic accumulates in gyres, large circular currents that thread through the world's oceans.
What's leaving land heading out to sea is all the single-use packaging. It's the straws, the bags, the bottles, the cup lids, the stir sticks, all this junk that we use once and throw away. A plastic bottle leaving California will get to Japan in about 3 to 5 years and come back across the northern half of the North Pacific. That's spinning mass of water as a gyre. Plastic trash will migrate to those zones and get stuck. We actually take boats out in the middle of nowhere, we drag our net behind the boat, and we count the plastic particles that are floating. Working with ocean modelers, we can get these regional maps of how much trash is out there, what it is, and where it is.
But answering even these basic questions about marine debris has proven to be surprisingly challenging. In fact, everything we know about the proverbial Great Pacific Garbage Patch started in 1990, when a container ship spilled 61,000 sneakers into the ocean.
Realizing that a lot of these sneakers would never come to shore, that they would just be stuck in this vortex. Curtis Ebesmeyer, working with James Ingram Jr. at NOAA, they're the ones that came up with the term Great Pacific Garbage Patch.
Captain Charles Moore is often credited with the first observations of the patch, a constellation of microplastic particles that captured the public's imagination.
Captain Charles Moore had described the area. He said, look, I'm in an area roughly twice the size of Texas where I'm doing my transects, and that hit the media by storm. But aren't these islands of trash? They don't exist. It's more like a smog of microplastic particles. Billions of them, very toxic over a wide area.
Even when they become brittle and break apart, plastic pieces persist. Unable to oxidize or become waterlogged like metals, wood, or paper, all types of plastic are designed to defeat natural decay.
In general, high-density polyethylene, number 2 plastic, is the most common plastic in consumer use. And it makes your soap bottles, it makes your toothbrushes, it makes many of the consumer goods that float out in the garbage patch.
If we think in terms of all the plastic that's been produced since 1950, since it's a synthetic material, hydrocarbons, it's probably still here today on the planet.
Dr. Sarah Jean Royer works with Dr. Nikolai Maximenko and his team at the University of Hawaii to tackle the problem of tracking trash.
Most of the time we will find only bottle caps and not the bottle itself, because the bottle is made out of PET and it's sinking because the density of PET is higher than seawater.
Despite the dramatic amount of plastic the crew of Seeker has encountered, some estimates hold that 99% of ocean-bound plastic waste is still unaccounted for. That's why Sarah's team is working with the swim expedition and the Ocean Voyages Institute to tag and track the waste they find.
The swim are using two different protocols. The first protocol is a visual survey of all marine debris they see from the vessel itself. And whenever they find an object that is large enough, they will get closer to the debris, they will take pictures of it, and if there are numbers or lettering, they will share this information with us so we can track back the origin of that debris. The second protocol is basically to attach GPS buoy onto marine debris to track their movement in the ocean.
We go to the net and tag it, and then we take out this and it's activate the tracker.
Once the tracker is activated, it enables scientists to both improve models of how trash travels in the ocean and learn where to focus cleanup efforts. Most of the time, Sarah and her team can't immediately tell where a piece of plastic comes from, but they can look for other clues.
We need to use an FTIR, or micro-Raman spectroscopy. This spectrum is matching a spectrum that is found in the library, telling us what is the type of plastic. It's probably the dream of all scientists to have a satellite and a new instrumentation to be able to quantify the amount of plastic floating at sea.
The entire life cycle of plastic is poisonous. Its manufacturing process depends on harmful chemicals, and when released into the environment, it soaks up even more toxins and transports them far and wide, including into our bodies. Plastic can choke the ocean's ability to absorb CO2 from the atmosphere, exacerbating climate change.
Only 10% of the habitat is on the land. The rest of 90% of the habitat's in the ocean, and it's totally unexplored for the most part. Imagining all the jungles, all the deserts, all the savannas, all the Rocky Mountains. The ocean would be 9 times more. And the idea that somehow it could be 50% plastic, 50% fish in a mere 30 years is horrifying.
The ocean is in peril right now. And if we don't do something that is going to reverse that in the next few years, then it's going to be much more difficult.
But the situation is far from hopeless. Organizations are developing innovative solutions to clean up ocean plastic. Material scientists are turning their attention to new packaging solutions, and consumers are making more informed choices every day.
How can we use our science to influence laws and policymakers?
When you refuse the single-use plastics, it has an effect on your neighborhood, on your local watershed.
All right, so I'm gonna stop the video here. Again, this is on my e-portfolio on Objective 2. Okay. Oh. All right. So, oh my God. So now we're gonna talk about basically the people that discovered it. So, firstly, even though oceanographers and climatologists predicted the existence of the Great Pacific Garbage Patch, this man right here, who was a racing boat captain by the name of Charles Marone, he actually discovered the vast vortex. So basically, Marone was sailing from Hawaii to California after competing in the yachting race and then crossing the North Pacific. So, Jared Morrow and his crew noticed millions of pieces of plastic surrounding the ship. Nice. And then here, by the name of Ed Carpenter, he was the first to report plastic pollution in the Atlantic in 1972. However, the Oxford Oceans in the South Atlantic near Cape Town, South Africa, which is right here, in the 1980s discovered pre-production plastic plants and balls of tar known as plastic tar balls falling from the flushing of oil tankers into the sea. All right. Now, favorite topic, plastic waste. So first, we need to talk about all of this, basically all of this plastic here. Ooh, there is a lot. So the amount of plastic found in the patch, well, there's a total of 1.8 trillion. Actually, let me do this in order. Well, firstly, the total 9.8 trillion pieces are estimated to be floating in the patch, which is equivalent to 250 pieces of breeze for every human in the world. And then 80% of the plastic in the ocean is estimated to come from land-based sources, while the remaining 20% comes from boats and other new sources. So if we look here this was in 2012. So 5 Gyres guided scientists established the world's first ever global estimate of marine plastic pollution, which they published in 2014. They found that there were 269,000 metric tons and 5.25 trillion particles on the ocean surface. Then let's fast forward a couple of years. The 2017 campaign of the United Nations Clean Seas estimated that there are 61 trillion microplastic particles in the ocean at that time, and 500 times more than the number of stars in our galaxy. And then 2018 study found that snake fishing nets made up nearly half the mass of the Great Pacific garbage patch. And this is due largely to the ocean current dynamics and increased fishing activity in the Pacific Ocean. I don't know if you guys are seeing that, but that is just so much, just so much plastic, and it looks like throughout the years it was just they were finding more and more and more and more. You probably wonder, well, why is there so much plastic? What you need to remember is that in the ocean, the sun breaks down these plastics into tiny, tiny pieces. This process is actually known as photodegradation. So photodegradation is basically a process in which a substance is broken down by exposure to the light. And again, there's also there is two reasons why plastic makes up the majority of marine debris. One, which that's the next slide. Yeah. So the reason why there's so much plastic, as I was saying, is one, plastic already those costs and mean that it's being used in more and more consumer and consumer products. And then again, plastic doesn't biodegrade, instead they break down into smaller pieces. So actually, basically, I'm wondering, well, how was this plastic basically measured in the Great Pacific Garbage Patch? The ocean cleanup actually used numerous methods, so I'll be talking about probably in the next part on how they measured this. So we're going to stop here and then we're going to come back.